Welcome to lesson 4.2, Reflecting Figures. So in our last lesson, we looked at how to reflect points. In this lesson, now we are going to look at how to reflect multiple points that create figures. So the first thing that we're going to look at is the reflection postulate. And the reflection postulate has parts A through E. So on the left-hand side here, it says what the postulate says. In the right-hand side, it tries to make it into more common language. So part A of the postulate says, under a reflection, there is a one-to-one correspondence between points and their images. So that final image of it. So each pre-image has a unique, meaning exactly one image. And each image has a unique pre-image. Part B, collinearity is preserved. So if 3 points are collinear, then their images, 3 points, are also collinear. So the image of a line is still that line. Betweenness is preserved. So if B is between A and C, then the image B prime would be between A prime and C prime. Then we have part D that says distance is preserved. So the distance from AB would be, the distance, so if A prime, B prime is a segment, and that's the image of segment AB, then the distance of A to B equals that distance of A prime to B prime. So in other words, when reflecting, that distance or length would not change. And then the last part, E, angle measure is preserved. So if angle B prime, A prime, D prime is the image of angle BAD, then their two measures are equal. So the measure of a pre-image of an angle is equal to the measure of an image of that same angle. And I lied, there's actually a part F too, got broken here. Part F says, orientation is reversed. So a polygon and its image with vertices taken in corresponding order have the opposite orientations. So if we look at this image up here, figure ABC, this segment, its orientation is reversed. Now it goes A prime, B prime, C prime from right to left. In the original, it went left to right, ABC. So that orientation, or the order of the points, is reversed. So like it says here, if a pre-image has a clockwise orientation, its image would have a counterclockwise orientation, or vice versa. So in example 1, they want us to graph triangle ABC with vertices A at -5, 2, B at 3, 4, and C at 1, -2. So that is the blue triangle that you see here in the graph. A, B, and C, connect them to create our triangle. Then we're graphing the reflection over the y-axis and giving the coordinates at A prime, B prime, and C prime. So remember, the y-axis is our vertical axis, so we will be reflecting over that line. If we're reflecting over the y-axis, that simply means the x values are what change. So if it was a -5, 2 for A, then A prime is a +5, 2. B at a 3, 4, B prime would be at a -3, +4, and then C at a +1, -2, C prime is at a -1, -2. So if you're reflecting over the y-axis, you change the sign of the x values. If you reflect over the x-axis, you flip the signs of the y values. So then the pink triangle here, A prime, B prime, C prime, is the reflection image of our original triangle ABC. Then the figure transformation theorem states if a figure is determined by certain points, then its transformation image is the corresponding figure determined by the transformation images of those points. So basically what that's saying is, if we are going to reflect an image, so reflecting pentagon A, B, C, D, E, F, or A, B, C, D, E in this case, F is just part of the point on a line. So if we reflect that pentagon, according to the figure transformation theorem, then the image of the corresponding figure is determined by each one of these points being individually reflected. That's what it means. So if we have a whole figure, the transformation theorem states that the image matches up the corresponding points. So I would reflect A over line M, reflect B over line M, which would be at the same spot. Same with F. Reflect C over to the other side to get C prime. Reflect D over to the other side to get D prime. And E over to the other side to get E prime. And I'll make a separate video showing how to reflect one figure so you get the example. But what you want to do, just like in the last lesson, it's the same process. You just reflect each point individually, and then you go back in and connect them to create the figure. And then we're just going to quickly look at this idea of orientation of figures. So although reflections preserve angle measure between this collinearity and distance, they don't preserve everything. The image down here, A prime, B prime, C prime, D prime, E prime, looks reversed to that pre-image A, B, C, D, E. When you think of walking along the sides of a polygon, going from vertex to vertex, you're assigning orientation to that polygon. Every polygon has two orientations. The orientation for which the interior is on the right as you walk is known as clockwise. When the interior is on the left, the orientation is known as counterclockwise. So if I look at A, B, C, D, and A prime, B prime, C prime, D prime, E prime, if we would put a little person there going from vertex A to B, then our interior would be on the right-hand side of that person. Or if we were going E to A, that interior is to the right. So this would be known as a clockwise orientation. On the other one, going from A prime to B prime, the interior is to our left, even though it's kind of down and left. Interior to the left of the person walking, so that would be counterclockwise. And remember, if the person's facing this way, then from B to C, their left would still be the interior being counterclockwise. So you would go in the alphabetical order around the exterior. So the orientation of figures is a new concept for this lesson. Reflecting figures, if you know how to reflect points, it's the same process. Then you just go back in and connect the points. And then that idea of reflecting over the y-axis means you change the sign of the x values. And if we were to reflect over the x-axis, we would flip the signs of the y values. And then just make sure that you keep track of this table for the reflection postulate pieces. And like I did in the last lesson, I will have a separate video walking you through the steps for reflecting a figure.